This was one of my first projects back in the day. I got bored of 3D printing toys and want to challenge myself with something useful completely designed by me. A lot has changed since then. On the other hand, there's this commercial product I used as a surge protector a decade ago. And both have one thing in common. They are trash. But they are different kinds of trash. Don't get me wrong, my project still works. But it was born out of my complete beginner mind, full of errors and room for improvement. I want to show you what went wrong to fast track your learning process, and hopefully, by the end of the video, you'll understand why this surge protector is a straight up scam, useless, and a risk just to have it around. Everything evolves. You're not the same person you were 5 years ago, and your knowledge has grown since then. The key is always to try and do better. Learn from your mistakes, and most importantly, from others. Now, let me reveal the 10 golden rules for mastering electronic projects, and apply them in a new power supply for my lab. Ensure your connections are robust. It's crucial for reliable, long-term functionality. Bare wires or loose filaments are time bombs waiting to explode. Solid connections prevent short circuits, even in changing conditions. Imagine having the toolhead of this 3D printing moving around with bad connections. It's a recipe for disaster. Every connection matters. Locate and eliminate any possible source of short circuits. If you can avoid exposed connections, at least cover them with insulation tape or heat shrink tubing, not with hot glue like this. This ensures both product and your safety while handling it. If you don't want your project to go up in flames, take care of your cables. Believe it or not, this directly impacts performance and durability. Opt for quality cables and select them based on the rated current they'll handle. Too thin cables for the working current can lead to voltage drops and become a fire hazard. Good cables instill confidence, no internal breakage, no overheating, and no risk to the environment where it's used. If possible, use cables with a datasheet, and test them before using them in your projects. When making connections, label your cables. It's not just a minor detail, it's a crucial technique for effective functionality and maintenance. Here, labeling or coding cables is a smart strategy to avoid confusion during assembly and eventual repairs. It translates to fewer errors during construction and greatly eases any future interventions. For simple projects, use an intuitive color code. This makes it so much easier and you'll avoid a headache. Check the link in the description to get the free Maker Mail newsletter and find more tips. This is my favorite rule. When making changes between connections, you'll thank me for this advice. Use appropriate connectors. Connectors have two main functions. Securely, robustly, and error-free transmit power of signal, and facilitate easy connection and disconnection for change and repairs. In an early stage, you can use Wago terminals. If your system relies on components you want to change easily, use connectors or terminals. This provides maintenance ease and design versatility. Choose connectors suitable for your application, capable of handling the current. Define a logical pinout to accompany your cable code. Have you ever asked yourself why all the components on a computer have the same type of connector? It's because standardizations allows the user to connect, disconnect, and change components with ease without risk and thinking too much. Don't make a monstrosity like this and procure to make good solder joints. Have your brush, paint, and the best technique on hand, because this should be a work of art. The key here is the cleanliness and precision of the solder joints. A well-made solder joint provides a solid foundation to face environmental and mechanical challenges. Guess what? It doesn't necessarily mean a large solder joint. In an upcoming episode, I'll teach you how to solder professionally with simple tools based on my experience as a certified PCB inspector. So you might want to subscribe to don't miss it. The time and attention investment in quality soldering guarantee your project withstands the test of time without compromising its performance. Visualize your project and know beforehand what are the geometrical constraints are, so you can choose components and plan for the final shape of the product. Take good measurements and try to design a product that works well and it's easy to use. Imagine your project as a three-dimensional space where every millimeter counts. Plan the design considering not only what you need to include, but also how the user will interact with the device. Easy of use isn't a luxury, it's a necessity. Think of your project as an everyday tool. If the design is intuitive, the user will adapt effortlessly, ensuring a hassle-free experience. You've got your design, but did you consider manufacturability, assembly, and repair? Planning is key. After the paper, your design will be manufactured. Make sure not to complicate things unnecessarily. This is the stage where you should anticipate problems. See the future. Efficiency planning cable routing not only improves manufacturability, but also avoids unnecessary crosses that could complicate assembly. It's not just about creation. Eventually, your project might need repairs. The ability to easily open it for inspection and repairs, it's a point that separates amateurs from professionals. Here, think of your project like a vehicle. Easy maintenance ensures a prolonged lifespan. Many of your projects will be with you for years, and, let's be honest, some unused. But when you need them, it's better that you've labeled their features. It's not just a nice to have. It's a strategy to ensure your project is understandable and usable for both the current and future users. Here, the key is to consider the most basic parameters, strictly what's necessary for a smooth operation. Not too complex to overwhelm the user, but not too simple for them not to know what to do. Congratulations, you have the product in your hands. Now, rigorously test the equipment. Dive deep into functionality, ergonomics, and user experience. Here, tests are not just to check if the device works. It's an evaluation of its limits and capabilities. Test all combinations to determine if there's any possibility of a system failures that need improvement. If so, be prepared for a new iteration. Evaluate functions, ergonomics, ease of use, and repairability. There's not better feeling than a job well done, even if no one else ends up using it. Letting a mediocre job exist when you can do it well means a step backward instead of forward. Bear with me in this one and understand the power of detailed documentation. Having a complete compilation of the technical information of your project would help you to recreate it on the future. I can't recall what the components of my project were, nor the code it had. So, if I want another one, I will need to go back again to the design phase. Imagine your project as a play of a century ago. How could you restage it without set designs, sheet music, character features, and custom designs? Without this, your work never happened. It's not for you, it's for anyone interacting with your creation in the future. This is what makes the difference between a successful project and one that fades into oblivion. Follow this tip in your projects and make it your finest work. Now that you're familiar with the method, you might want to kickstart your own electronic projects. But what's all this electricity thing about? What if I told you that, with this wheel, you can master all electricity? Click on the next video to finally understand electricity the simplest way.